Okay, third part of this tutorial is on impulse, which is change in momentum, delta P in this case. Or sometimes people write it I, it doesn't really matter. But from this equation, delta P equals F delta T, we can calculate impulse in any case. Now, impulse is the result when momentum is not conserved. Say, when a person falls head first into the ground. Now, obviously, the earth isn't going to move off because somebody falls into the ground. Otherwise, yeah, it would be like way out of order or something. Anyway. In this case, the momentum has to be changed to 0. Now, of course, the initial momentum of the body falling down to earth is not 0. So a force must be applied in order to decrease this momentum back to 0. So this force is, in this case, of a person falling down to the earth. This force results from the upward resistance force of the earth. So it kind of just pushes the person back up. And this collision happens over a certain period of time. Now, sometimes in our lives we think that collisions are just 0 seconds. But we've learned that it's not. It takes a very small amount of time, but amount of time anyway. So, a lot of explanation questions that I've seen in the past few exams, 2004 to 2013, most of them ask kind of the same format of question regarding bicycle helmets. Now, say you have a person falling down head first into the earth, say in a bike accident, and he's not wearing a helmet. Now, his time of collision, his change in momentum is the same, because he has to decrease the velocities by the same amount. However, the time taken for him to completely stop, i.e. for his change in momentum to completely occur, is going to be less than the amount of time taken, say, if he were wearing a bicycle helmet. See, bicycle helmets, they crumple on impact, so they kind of take more time they provide more time for the body to collide with the earth, i.e. for the momentum to completely go down to 0. Now, in these two cases, the change in momentum is the same. So always state that in an explanation question like this, the change in momentum is the same for both cases. However, the time taken for the change in momentum to occur is different. In the case of wearing a helmet, the time taken for the change in momentum is larger. While when not wearing a helmet, the time taken for the change in momentum to occur is shorter. Now, from this equation, since delta P, impulse, change in momentum, is constant, but time is different, then the force applied in both of these cases must be different as well. Since time is shorter here, i.e. delta T is decreased, then the force has to increase in order to keep the change in momentum constant. So, this guy you gotta feel sorry for him. The force that the ground exerts on him is going to be larger than if he were wearing a helmet. So he's obviously going to get more brain damage from falling down to the ground. If he's wearing the helmet, delta T will be increased because he takes more time to completely slow down and go to a momentum of 0. So delta T has increased. That means that force must decrease in order to keep delta P, change in momentum, the same. So he's going to be lucky. He's not going to have that much brain damage when he falls to the ground, because the ground is exerting less force on his head than if he were not wearing a helmet. So this is just one of the most common questions asked in exams. Now we go into the fourth part of this tutorial on center of mass. Now, in a system containing two or more bodies in it, then mass does not lie with only one object. It lies somewhere in between the two objects. Now, think of a case where we have two astronauts holding a weightless rope, a rope of negligible mass, in space. Now, one astronaut is bigger than the other. So obviously, its center of mass, this system's center of mass, is not going to be directly in between these two astronauts. So how are we going to find the center of mass? Well, take the mass of the smaller person as small m, and the mass of the larger person as big M. Okay? Now the distance between these two people is d. Okay? So now say the distance, say we want to find the distance between the center of mass and the smaller person. We'll call that small x because it's closer to the small m, small mass. Now the ratio of mass, so small mass over large mass, small m over big M, should equal the ratio of the distance between the smaller mass and the center of mass over the larger mass over the center of mass. The large mass and the center of mass. So, in this case, I don't know if you can see it properly, but the distance between these two people is d. The mass of the smaller person is small m. The mass of the larger person is big M. The distance between the small person and the center of mass is small x. And the distance between the bigger person and the center of mass is big X. So as we've written here, this must mean that m, small m over big M, must equal small x over big X. Now, big X is practically equal to the total distance between these two people minus the distance between the small person and the center of mass. So big X is equal to d minus x. So that helps us get rid of one variable, big X. And so we find ourselves with small m over big M is equal to x over d minus x. Now we cross multiply so that we get m times, in brackets, d minus x equals big M times small x. And when we rearrange that in order to get the small x, which is what we want, the distance between the small mass and the center of mass, what we get is x, small x, equals small m times the distance between the two people, d, so small m times d, all divided by the small mass, small m, plus the big mass, big M. So x equals md over m plus n. And there you have the center of mass, but only in terms of how far it is from the smaller mass. Now if we wanted to make it the distance from the larger mass, then we pretty much only have to switch a few things. So in the case of trying to find the distance between the center of mass and the larger mass, you really only have to change small x to big X and change the numerator of the equation, small m, to big M times d. So if we wanted to convert, it would just be big X equals big M times D over small m plus big M. No big deal.